All right, today we're going to be working on connecting different types of quadratic expressions and information that they give us. But we're going to start with a warm-up, just practicing factoring some quadratics. You'll really need to have a solid handle on factoring for Math 2. So we're just going to start with a little warm-up, reviewing what you did in 10.5 and 6. So we'll just factor these trinomials. So since A is 1, I can just sort of figure out, all right, I'm going to use this diagram. What numbers multiply to 18 and add to 9? So there's lots of numbers that multiply to 18, like 2 times 9, 18 times 1, but 6 and 3. We'll use 6 and 3 because 6 and 3 add to 9 and multiply to 18. Now, since A is 1, I don't have to go through a bunch of other steps to figure out what the factored form is. When A is 1, I can actually just use these numbers that I found, and I just know that the factored form is x plus 6 times x plus 3. And you could check it if you wanted to by foiling, like multiplying it out, and you should be able to get back to where you started, like x times x squared, x times 3, 3x, 6 times x, 6x, 6 times 3, 18, and you can see that this will give you what you started with, so it checks out. You don't always have to do that, but if you're not sure if you factored it right, then it's probably a good idea. Okay, so over here we have, again, we have A is 1, so I'm just going to figure out numbers that multiply to 8 and add to negative 6. Make sure you have that sign in there, negative 6. So if this number down here is negative and this one's positive, I know that both of my numbers here have to be negative, because the only way I'm going to add to a negative number and multiply to a positive number is if both of these numbers are negative. So I need to think of numbers that multiply to 8 and add to 6. So that would be negative 4, negative 2. And it really doesn't matter which order you put these in. It could be negative 2, negative 4. And since A is 1, I can just say, okay, I already know. I don't have to do any more steps. I already know that the factored form is x minus 4, x minus 2. And then I'm done. And you could check it if you weren't sure. Okay, now on number 3, though, the A is not 1. So you're going to have to go through a couple more steps to actually factor this. Like, you can't just figure out what these numbers are and then plug them in like we did before, because A is 2. Okay, so up here, I'm going to put, so this I have A, B, C. So up here goes A times A times C. So 2 times 15 is 30. And B is 11. So I need numbers that multiply to 30 and add to 11. So that would be 5 and 6. So I can't just put, x plus 5 times x plus 6 as the factored form. So what this actually does, what this 5 and 6 actually does, is it splits the middle term up into 2 terms so that I can do grouping. So I'm going to do 2x squared plus, and instead of 11x, I'm going to write 5x plus 6x plus 15, right? So that's all I need those middle numbers for, is to split that up. Okay, so now you can either factor it with a Punnett square, like Mr. Jenkins showed in the last video. Like, you can put each term in a box because you have 4 terms. You can only do this when you have 4 terms. And then factor out the greatest common factor from each column and row. Like, the greatest common factor here is 2x. The greatest common factor here is 5. Greatest common factor here is x. And greatest common factor here is 3. Oh, just 3. Okay, so I can see I can do that. Or I can go over here and I can just factor by grouping. Like, take the first 2 groups of numbers and say, all right, what's the greatest common factor? Well, the greatest common factor of these 2 terms is x. And then what do I have left to get back to there? 2x plus 5. And what's the greatest common factor of these two terms is 3. And what do I need to get back to 6x plus 15? 2x plus 5. So I get x plus 3. Since x and 3 are both being multiplied by the same thing, I just put them together, and I'm going to multiply them by 2x plus 5. And you can see that's what we would have got as our dimensions for the model, is 2x plus 5 times x plus 3. All right, over here we have an A, a B, and a C, and our A isn't 1, so we're going to have to go through those steps again. So since I want A times C up here, 5 times 18 is 90, and then I put B down here, which is 19. So what multiplies to 90 and adds to 19 is 10 and 9. So I'm just going to use 10x and 9x to split up this 19 so that I actually have 4 terms. So I have 5x squared plus 10x plus 9x plus 18. And now I have 4 terms, and I can either go here and use a Punnett square, like put 1 in each box, but I think it's just easier to graph by grouping. But if this is easier for you, then you should use that. Okay, so what is my greatest common factor out of these first 2 terms? Well, 5x. And then what do I need to get back to it? X plus 2. And then what is my greatest common factor here? 9. And what do I need to get back to it? X plus 2. So since 5x and 9 are both being multiplied by the same things, then I'm going to put them together, 5x plus 9, and they're both being multiplied by x plus 2. So this is my factored form. And again, if you're not sure you're correct, then you can just FOIL it out and see if you get back to where you started. Okay, so the instructions here on the warm-up say, find the value of x that creates a product of 0. Find the value or values of x that create a product of 0. So, like, why would you want to do this? Why? Why would you want to know when this quadratic equals 0? Why do you want to know? Well, I mean, what happens when y is 0? So, like, it would normally be, right, like x minus 4 times x minus 3 equals y. Well, what happens when y is 0 is that's where the x-intercepts are. So, x-intercepts are where y equals 0. So if you can figure out what would cause these factored forms to equal 0, then you know what your x-intercepts are. So that's a good thing. All right, so we're going to use zero product property. So we talked about zero product property in previous videos. Zero product property means if you're multiplying 2 things or more and the product is 0, then at least one of those things has to be 0. So in this case, either x plus 9 equals 0 or 4 equals 0. Well, we already know that 4 doesn't equal 0, so we're going to just solve this equation for x. So I have x equals -9. So what does that mean? That means that for this quadratic, if I was going to graph it, I know that I have an x-intercept at -9, 0, right? Because this is my x and the y was 0. Okay, over here, this factored form is either x minus 4 equals 0 or x minus 3 equals 0. That's what zero product property would say. Like, that's the only way you can multiply 2 things to get to 0. So I have x equals 4 and I have x equals 3. So I have 2 x-intercepts. One is at 4, 0, and the other one is at 3, 0. So that way it gives me a clue to graphing that quadratic, is what the x-intercepts are. These x-intercepts are also called roots. We'll talk about that later. All right, here I have 2x minus 1 equals 0. X plus 8 equals 0. So I have 2x equals 1. X equals 1/2. Okay, so one of my x-intercepts is 1/2, 0. And the other x-intercept is -8, 0. Okay, so later on, when you're asked, what information does a factored form of a quadratic give you? Well, one thing that you can easily find is x-intercepts. Okay, so now we're going to look at, let's see if I can fit this whole thing in the screen. Okay. All right, now we're going to look at, we have different forms of quadratics, and we're going to just look at what information can we get from them that will help us to graph or just give us general information about this quadratic. So I'm going to, at the top it says, for each function below, find the features of functions. Remember, I think it was module 7, where we talked about features of functions, and write the function in the other forms, standard form, vertex form, factored forms. Graph each function and be sure to write the intercepts as points. It's saying to be sure that I write the x-intercept as like ordered pairs. It's not like the x-intercept is 6, the x-intercept is 12, or whatever. You write them as ordered pairs. Okay, so now recognize the form that you have and see what you can get readily from it. Well, what we just did on the warm-up was we were like, oh, we found the x-intercepts when y is 0. Okay, so remember, x-intercepts happen when y equals 0. So just go ahead and you have factored form. So if I have 0 equals x minus 1 times x plus 3, then if I set this equal to 0, I would get 1, right? That would make the value of 1 in here for x would make this 0. Okay, so that's one of my x-intercepts, 1, 0. And the other one, what would make this parentheses 0? -3. -3 plus 3 is 0. Okay, so that's my other x-intercept. Okay, now how do I get the y-intercept? Well, the y-intercept is when x equals 0. Makes sense, right? Okay, so now I have y equals, and in my equation, I'm going to plug in 0 for x, because I get the x-intercepts when y equals 0. I get the y-intercept when x is 0. So everywhere that there's an x, I'm going to plug in 0. So I have 0 minus 1, 0 plus 3. So -1 times +3 is -3. So my y-intercept when x is 0, y is -3. Okay, axis of symmetry. There's a couple ways you can find axis of symmetry. Now you can first find your vertex, and then you know the x value is the axis of symmetry. But another way you can find axis of symmetry is think about your x-intercepts. Okay, my x-intercepts here are 1, 0 and -3, 0. So doesn't the axis of symmetry have to be exactly in between them? So you can just find the average. So you can just say, oh, axis of symmetry, it has to be the average between my x-intercepts. So -3 plus 1 is -2 over 2, which is -1. So I know my axis of symmetry is x equals -1. I know that it's right here. But I can wait until later to find that out. Okay, so now it's asking me for my vertex. I can actually plug x equals -1 in to the equation and find the y value for my vertex, because I know my vertex is on the axis of symmetry. So I'm going to go ahead and use my equation and plug in -1 for x. So I know that y equals -1 minus 1 times -1 plus 3. So -1 minus 1 is -2. -1 plus 3 is 2. So I know that my vertex is on the axis of symmetry, so -1, and it's at 4. So right now I have -1, 4. 1, 2, 3, 4. Okay. So far I haven't even changed it to vertex form, but I found a lot of information just from my factor form. Okay, this minimum maximum, it's really asking you, do you have a minimum or do you have a maximum? Well, since A is positive, it's like there's a +1 here, I already know that my parabola is going to look like this. So I do have a maximum, and when you write what a maximum is, it's just the y value, but you don't have to write it as ordered pair. I just know that the maximum is the y value from my vertex, so it's just 4. Because minimum and maximum is always a y value. Okay, domain. If I kept, well, for all parabolas, you have the domain of -infinity to +infinity. The reason is because it's going to continue to go, as it continues to go down, it's going to continue to go out and forever and ever. Now, range is always from bottom to top on the y. Like, from what's the lowest value of y? Well, the lowest value of y is going to be -infinity, right? Because it's going to keep going down. But my highest value for my range is my maximum, which is 4. And that's included, so I'm going to use bracket. Okay, for standard form, I'm just going to go ahead and FOIL this factored form. So I have y equals x minus 1 times x plus 3, and I'm going to multiply it out. So I have y equals x squared, and then minus 1x plus 3x is plus 2x. -1 times 3 is -3. Okay, this is my standard form, like ax squared plus bx plus c. And then from vertex form, I'm going to start with standard form, and I'm going to find my vertex form by completing the square. So I'm going to start with, remember, for vertex form, you start with ax squared plus bx. You take half of b and square it. So half of 2 is 1, and I'm going to square it. So I'm going to add 1. And then that 1 that I added, I need to take it away. And I need to bring down this -3, right? Okay, so what I did now is I just created a perfect square trinomial. This is x plus 1 quantity squared, and then minus 4. So this is my vertex form, y equals x plus 1 quantity squared minus 4. Now, if I hadn't found my vertex before, you can see it in vertex form, right? -1, -4. No, -1. Well, this was -1, -4. Sorry, -1, -4. Oops. Sorry, since this, I did make a mistake. Since this is positive, I know my problem is going to go like this. This is not right. Okay, so I have -1, -4. All right, we got it right. So it's good, I guess, to have it both ways to make sure that, but you know that it's going to go this way because this is positive. I totally made a mistake on that. All right, so now I only have 3 points, and that's a little bit of an issue. So what I want to do is also, well, I can also put in my y-intercept, 0, -3. Now I only have 4 points, and it's always good to have at least 5 points when you sketch a quadratic. Now see how this y-intercept is only 1 away from the axis of symmetry? I can actually go ahead and graph my 5th point over here on its reflection. And then just do your best to sketch a smooth curve. You don't want to make it look like a V, because then it looks like an absolute value function. Okay, so sorry about this little mess up. All right, let's look at this one. Something you know about this this graph already is that it's because A is 2, that you know that it's going to make it more narrow. So expect that on your graph. And since it's positive 2, you know it's going to go up like this. So I always just try to sketch it, see what it's going to look like. Okay, it's in factored form. So what are my x-intercepts? What would make this 0 is 2. So one of my x-intercepts is 2. What would make this 0? 6. So 6 zeros, another x-intercept. And then for y-intercept, it's when x is 0. So if I plug in, I'll do it over here inside. If I plug in x is 0, 0 minus 2 times 0 minus 2 times 0 minus 6 in my equation, this is negative 2 times negative 6 is 12 times 2 is 24. So my y-intercept is 24, 0. That's not going to fit on this graph, but it does make sense that it would be 24, 0 because remember this is going to be really narrow, so the y is going to grow really fast. Okay, what's my axis of symmetry? Well, my axis of symmetry is in between my x-intercepts. So my axis of symmetry has to be x equals 4. Okay, so these are the points I have right now. 2, 0, 6, 0, 24, 0, which I can't graph because it's way up there. But I do know my axis of symmetry is right here. Okay, it's a good place to start. How do I find my vertex before vertex form? I just plug in. I already know that my x value of my vertex is 4, because remember it's on the axis of symmetry, but I got to find the y value. So I'm just going to plug 4 into my equation. So 2 times 4 minus 2 times 4 minus 6, and I get 2 times negative 2, which is negative 4 times 2 is negative 8. Okay, so my vertex is 4, negative 8. I can go ahead and graph that. This is looking good, but you see how it's really narrow? It's really going to be narrow. Okay, what's my minimum, maximum, or which one do I have? Oh, and back up here, I need to change this. Remember that I made a mistake? I had a minimum, and it was negative 4. Okay, so I do have a minimum on this one also, because it opens upward, and my minimum is negative 8. What's my domain? Negative infinity to positive infinity. What's my range? Well, my range goes from, oh, I have to go up here and fix my range also. My range was negative 4 to infinity. I'm going to mess up that first one. Okay, so range is my lowest y, which is negative 8, inclusive, all the way to infinity. Remember, it's my lowest y to my highest y. Standard form, I'm just going to multiply this out. So for standard form, I'm going to go ahead and multiply these, and it's going to give me my standard form. So I have 2 times x squared minus 8x plus 12. So I have 2x squared minus 16x plus 24. And then vertex form, I need to complete the square. So remember, the first thing you have to do is make a 1. So first I have to factor out this 2. So I'm going to kind of keep this 2 out here. I have 2 times x squared minus 8x plus 12. And I'm just going to sort of forget about this 2 right now. Just work on this. So I want ax squared minus bx. So x squared minus 8x. Half of b is negative 4. Square it, you get 16. Okay. And then I have to add my 12. Take out the 16 that I added. All right, so now I have a perfect square trinomial, x minus 4 quantity squared. Remember, this number is always half of b. And then I have this plus 12 minus 16, so it's minus 4. Now I need to bring back this 2. Because remember, I kind of forgot about it. Okay, so my vertex form is 2 times x minus 4 quantity squared. And then I have to remember, this is the part that students often forget. I have to multiply 2 times this number as well. So minus Okay, so I don't have any other values in here to make a good sketch. So I'm just going to choose a value to plug in. Like just choose an X that's going to be in between these. So it gives me a good idea like where there's a point in here. So 5 is in here. So I'm just going to choose X equals 5 and just plug it in. So 2 times 5 minus 2 times 5 minus 6 is 2 times 3 times -1. So -6. So 5, -6. And then I can reflect it over the other side of the axis symmetry. And then it gives me more points to give me a better sketch. I'm going to go ahead and try to sketch this. When they're really near, it's hard not to make a V. Okay, so that's our sketch. All right, so both of those were in factored form. It gave us a lot of information. But now we're going to work on the same pieces of information, but from, oh, this one's factored form also. Okay, so now this is negative. So I already know that it's going to look like this. And it's going to have the same width as the parent function, y equals x squared. Okay, x-intercepts. Well, either -x equals 0 or x plus 4 equals 0, right? We use the zero product property. So one of the x-intercepts is 0, 0, right? And then one of the x-intercepts is -4, 0. Okay, how do you find the y-intercept? Well, if the x-intercept is 0, 0, then the y-intercept has to be 0, 0. I mean, you can go ahead and plug in 0 for x, and you'll realize that. Axis of symmetry. Axis of symmetry is always between my x-intercepts. So axis of symmetry must be at x equals -2, because I have 0, 0, and 1, 2, 3, 4, -4, 0. So I know my axis of symmetry is here. And then vertex, I already know that my vertex is going to start with my axis symmetry, and then I got to figure out what the y value is. So I'm going to go ahead and plug in -2 in my equation. So -2 is 2 times 2 is 4. Is it a minimum or a maximum? This one definitely has a maximum, and this time it's right, because I already know it's going to look like this. What's the maximum? It's whatever my y value is, so my maximum is 4. Okay, so -2, 4. All right, my domain, still -infinity to infinity. Range is going to be the lowest y, which is -infinity, to my highest y, which is 4, inclusive. And then standard form, I'm going to go ahead and multiply this out. -x times x plus 4. So my standard form is going to be y equals -x squared minus 4x. It just doesn't have a c. Well, the c is 0, so that's why this is 0, 0. Okay, vertex form. All right, remember I want a to be 1, so I have -x squared minus 4x. But I want a to be 1, so I'm actually going to factor out the 1, so I have this. Okay, now I'm going to ignore this -1 until I get down to the bottom, okay? So we're just going to look at this. So I want to complete the square. I have x squared plus 4x. Half of 4 squared is 4. So I have this, and then I want to subtract the 4 that I just added to make it what I wanted, right? And then I have a perfect square trinomial, x plus 2 quantity squared minus 4. Now I need to go ahead and multiply this -1 back into this, so I have my vertex form. So I have negative x plus 2 quantity squared plus 4, because I had to distribute that negative over here too. Okay, so again, I really don't have another point. So I'm just going to choose a point in here to give me a good I already know that it's going to keep going out here, so I'm going to just choose x is 1. Like if x equals 1, what's another point that I could graph out here to give me a good, sketch a curve? So -1 times 1 plus 4, so -1 times 5, so -5. So 1, -5 is a point. 1, -5. And then this point is 1, 2, 3 away from my axis symmetry. So I'm going to go 1, 2, 3 on the other side. And then go ahead and sketch through. Right. So I would actually encourage you right now to pause the video and see if you are able to do number 4. This is standard form, so the first thing you'd have to do, standard form, you're going to have to find factored form, you're going to have to find vertex form. So I would pause right now and see if you can get all this information from this problem, and then I'm going to do it for you, and then you can check your answers. At least you'll know if you're on track. Okay, so I know that this opens upward because A is positive. So that's the first thing. My x-intercepts are when y equals 0. So it probably would be helpful. I mean, I can go ahead and plug in y equals 0 and solve, but it's going to be helpful if I find factored form first. So I'm actually going to find factored form first, because that'll easily give me my x-intercepts. So I need numbers that multiply to 8, add to 6. So that would be -4. Oh, add to -6. Ooh, I almost forgot that. And -2. Okay, so since my A is 1, I know my factored form is y equals x minus 4 times x minus 2. Okay, now that means that my x-intercepts are 4, 0, and 2, 0. Okay, my y-intercept is whenever x is 0. So x 0 squared plus, minus 6 times 0 plus 8. So I already know that it's 0, 8. My axis symmetry, remember, is in between my two x's. So what's between 2 and 4? 3. X equals 3. What's my vertex? My vertex is whatever, whatever. Well, I know it's going to start with 3, and then I need to find the y by plugging in x. So I have 3 squared minus 6 times 3 plus 8. So 9 minus 18 plus 8, and I have -1. Okay, does it have a minimum or a maximum? It has a minimum, because it's going to open like this. What's my minimum? It's whatever my y is. What's my domain? -infinity to infinity. What's my range? Well, it's going to be my lowest y, which is -1, to my highest y, which is infinity. And I need to find vertex form. So I think the easiest way to find vertex form is to start with standard form. So I'm going to go back to my standard form, x squared minus 6x plus 8. And I'm going to start, and I already have a as 1, so that's good. So I'm going to start with x squared minus 6x. Half of -6 is -3. Square it, and you get 9. I got to add my 8 back in here. I have to subtract my 9 that I already added. And then I have a perfect square trinomial, x minus 3 quantity squared, and then -1. Right? Okay, so this is good. Y equals. So y equals x minus 3 quantity squared minus 1. All right, let's go ahead and graph it. So my vertex is 3, -1. My x and y intercepts, my x-intercepts, my y-intercept, and I don't need to really pick another point because I can just reflect my y-intercept over the axis symmetry. So it's 1, 2, 3 away. I'm going to reflect it 1, 2, 3 on this side. And then I have 5 solid points to sketch a smooth curve. There you go. So hopefully if you pause the video and you tried it on your own, hopefully you were able to get it right. Okay. So based on these examples that we just did, how can you use a quadratic function in factored form, like y equals x minus p times x plus p times x plus q? That's kind of how we write the general factored form. How can you use factored form without changing it to another form, like without changing it to vertex form, how can you use it to find x-intercepts? Well, use zero product property, which is finding when y equals 0. So we're just going to use this example throughout this, all these questions. So if I have, for example, y equals, let's say we have this factored factored form of a quadratic. I'm going to make my y into 0. 0 equals x minus 4 times x plus 2. And use either x minus 4 equals 0, x plus 2 equals 0. So x equals 4, x equals negative 2. And my x-intercepts would be 4, 0, negative 2, 0. So that's how I can find the x-intercepts from factored form. How do you find the axis of symmetry of the parabola? Well, it's the midpoint of the x-intercepts. So, using my example again, my x-intercepts were 4 and negative 2. So 4 plus negative 2 over 2 is 2 over 2, which is 1. So in this case, my axis of symmetry would be x equals 1. Find the vertex of, how do you find the vertex of the parabola? Well, you plug in x plug in the x from axis of symmetry to the equation. Okay, here's my example again with the same quadratic. So I want to know what the vertex is. Well, I already know that it starts with the axis symmetry x, which is 1 in our case, remember from the previous problem. So I want to just plug that in to my equation. So 1 minus 4 times 1 plus 2. So negative 3 times 3 is negative 1. And I'll go ahead and make that the y part of my vertex. How do you find from factored form the y-intercept of the parabola? Well, when x equals 0, you get the y-intercept. That's always true. So for my example, I'm going to plug in x equals 0. So I have y equals x minus 4 times x plus 2. So I have negative 4 times 2. And so I have negative 8. So my y-intercept would be 0, negative 8. Explain how you can convert a function in factored form into vertex form. So I think you need to actually go from factored form to, I think, the easiest way. Factored form, go ahead and FOIL it to make it standard form, and then make it vertex form. So, and this, you do this by completing the square. Okay, so let's use our example above just to show how you do that. So it started in factored form. This was our factored form, right? And then I'm going to change it. I'm going to go ahead and FOIL it to make it standard form. X squared minus 2x minus 8. And then I'm going to complete the square to make it vertex form. So I'm going to do y equals x squared plus 2x. Take half of 2, square it. You have plus 1. Bring down your negative 8. Subtract the 1 that you added in. Here you have x plus 1 quantity squared minus 9. So I have factored form, factored form, standard form, and vertex form. Okay, so hopefully that helps you get through 10.7. And actually, I think 10.7 is a really great, I think what we did covered a lot of territory. And it's really, if you can understand all that we did in 10.7, then I think that you'll be on a good course for taking the Module 10 test. All right, thanks a lot. Have a great day. Good luck.